Hello students, today we will learn about dual nature of light and de Broglie hypothesis one by one consecutively. So our lecture is as we have learned that in previous chapters during the phenomena of interference, diffraction, and coloration, we gathered information about light is a wave. So we can write down certain phenomena which can be explained based on wave properties of light, or number one, interference and diffraction. Reflection, and so on. There are so many there are so many phenomena we have explained based on the wave properties of light, and I have mentioned few of them where uh, we we use light as a wave. Simultaneously, and on the other hand, better to say, we have such kind of other properties as already we have learned Planck blackbody radiation as well as Compton effect. Before that, in class 11 12 standard, we have also learned photoelectric effect. And the information we have gathered from 11 12 on photoelectric effect, that classically it is almost impossible to explain the the emission, the incidence of light on a light sensitive surface, and the emission of electron may be a time consuming process. So there will be a delay between the incidence and the emission of electron. But it is observed that practically it is observed that there is no time gap really exist in between the incidence of light and the emission of electron. Classical theory cannot explain that phenomena and that observation uh, uh, in a better way. Why it is so? But quantum mechanically, first scientist Einstein proposed that if we consider light wave as a packet of energy or a bundle of energy as a module, and when it collides with the surface atoms and the surface electron of a photosensitive material, then immediately it transferred its energy to that electron, and electron ejected out from that material or coming out from that material immediately without hampering any other things. So, in this process, Einstein uh, explained quite satisfactorily that why there is no time gap really exists between the incidence and the emission of electron. So, and that idea, Einstein idea of packet of energy or the quanta of energy is not basically proposed first by Einstein rather than in Planck blackbody radiation by Planck. Planck first proposed that any black body, when it emits, according to Planck, he assumed certain things in order to explain the Planck's black body radiation. And one of the major striking assumption is that when the light coming from a black body, those are coming out in a packet manner or a quanta manner. Quanta is also a packet of energy, and having energy value is nu. This nu is it depends on the level from which a harmonic oscillator, which is also another assumption by Planck, making a transition from higher orbitals, higher state to lower state. That is when any when any atom or oscillator emits coming from any level n to a lower level n minus 1, then only we can expect such amount of energy with certain multiplied with certain integer depending on the level of emission. This is the concept first governed by or utilized or proposed by scientist what we call Planck, which satisfactorily explain the phenomena of uh, one minute please. হ্যালো আমি এখন একটু ভিডিও পেতে গেলে একটু কাজে আছি বুঝলে ওকে হলে ছেড়ে দাও হ্যাঁ ওকে ইলেকট্রিক্যাল ডিপার্টমেন্টে পাঠিয়ে দাও বুঝতে পারছো হ্যাঁ ওকে পাঠিয়ে দাও sorry for the report for the disturbance here and what I have while we were discussing about Planck's black body radiation where first the quanta of energy proposed. This is the quanta of energy. This quanta, uh, this quanta is not continuous rather than a discrete values which is coming out from that black body. So this discreteness or quantization also proposed by scientist Planck, and this is also utilized in photoelectric effect. In order to explain the photoelectric effect, it is also utilized. Not only that, in between we have also we at that time Compton effect is discovered, where also they have used high frequency radiation to find any kind of radiation changes after collision based on the energy transfer. Whatever they are getting, all are considered to be as a Magel type striking. That means particle nature. Particle natures are these kind of phenomena are explained, can be explained based on the particle nature of light. Whereas on the other side, I have also mentioned that uh, these are the phenomena which can completely explained by weak theories of light. We cannot explain those phenomena based on particle nature of light. So, but it is true. It is true that uh, 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 the particle nature and the wave nature are mutually exclusives in nature, because any kind of wave is nothing but a infinitely extend wave train spread over space, infinite extent, and also for longer duration. That means I can say that any kind of wave, ideal wave is nothing but it's a infinite extent wave train having gradual crest and trough, and it also spreaded over space as well as space, 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 and also time. Okay, these are the spaces. So, but we know particle nature is only explainable as we have obtained the concept from Newtonian mechanics that any kind of particle related or associated properties are mostly dependent on a particular position and a particular time. So it depends on particular position and particular time. There is no such spreading of spaces, and the spreading in time coordinates are present here. That means these are the properties valid for a particular instant of time as well as particular instant of time as well as particular position. So how they can be they can be connected to each other. It is almost impossible. But cleverly, scientist D. Broglie proposes that uh, we can draw a bridge between themselves, and already it was according to his what do you call according to his proposal, better to say, because it is a hypothesis at that time, it is not experimentally verified. So it's a proposal, and according to him, uh, de Broglie proposal. Okay, de Broglie, what proposal proposed by de Broglie? He dragged the Bohr theory according to Bohr theory. Bohr assumption. According to Bohr assumptions, uh, 2 pi Rn must be equals to m lambda. What it suggests? Now, whatever be the orbitals present in an atom, this is the nucleus, and this is the electron, which is revolving around it. I have drawn here one such orbitals, maybe two or three. The electron uh, revolving around the nucleus, during the revolution around the nucleus, it will complete integral number of oscillations during the revolution around the nucleus. Always, it would not be a fractional in terms of what do you call wavelength. Maybe the number of waves it completes executing in these second orbitals different with respect to or three third orbitals, and also would be different for second orbitals also. And according to Bohr, in any orbit, nth orbit, if its circumference is 2 pi rn, then it would be equal to n lambda. Okay, because it is the path length, and this is dimension also path. So from there, I can guess the radius of that orbitals is m lambda by 2 pi. Now, it is assumption number one, and according to Bohr quantitation principle, angular momentum. Quantization principle. Quantization principle. We can write we can write m b r a equals to NH cross, where H cross is H pi 2 pi. Okay. That is H pi 2 pi. So this integral number of H cross. So if I put the value, what we have obtained is that suppose if we consider this is as equation 1, and this is not summation at all, rather than if we consider this as equation number 1 and put the value from equation 1 here, then MP Rn is m lambda by 2 pi equals to NH cross. And from that we have obtained we can obtain lambda equals to, so n over, and and it is h by 2 pi, and it is 2 pi, and it is m and v. So all those 2 pi gone, it would be h by 2 p. Now look, here is the beauty of this assumption is that from that Bohr orbital theory, you can also reach a situation where wavelength of any particle, wavelength related to any particle revolution, is connected to its momentum and a constant parameter which is known as Planck's constant. So this clue leads de Broglie to propose de Broglie hypothesis. According to de Broglie hypothesis, uh, as similar as the light, as you have already on both sides, that light in certain cases follows wave properties, in certain cases can those phenomena explained by particle property. Also, certain teeny elementary particle, as for example electron, also follow such kind of rules. And truly, after proposal, though experimentally not verified, uh, first experimented by scientists Division and Jarber, and they have shown that if we in their experiment they have shown that this theory is truly magnificent, signifies that elementary particle possessing a certain momentum and have a discrete nature uh, is equivalent to or is related to a wave property having wavelength associated with it is such. Okay, we will come later how they propose. But so this is the pathway, or this is the gateway through which our what do you call our de Broglie proposes this dual nature of light. And here I have initially mentioned the what are those particle nature and what are those what are those wave nature and how they have proposed this what you call de Broglie hypothesis. This is the de Broglie relation. Okay, this is relation. We will practice certain problem based on this hypothesis, based on this relationship. But one point is sure that as I have shown that uh, wave is an infinite train which is spread over space, long space, infinite extent, as well as it also spread over a long duration of time. So one side it is wave property. In another side, we have also observed that this is the particle nature where it goes, where it goes, where it goes. Where it goes? Yes. On the other hand, we have a particle nature of light, where particle can be thought to be exactly positioned at certain instead of time at certain place, not spread over the region. So they are, as I have already mentioned, they are mutually exclusive. So how can I relate them? It is very difficult to relate them, and we can only relate if we rather than considering a single wave, consider so many waves related to a particle. If we obtain a wave which is spread over a small region in space, then only it can thought to be similar kind of as a particle. That means we have to squeeze your infinite spreading to a small section of space and in a small duration of time. Though maybe there will be a certain spacing in their position depending on their uncertainty. So we can relate them only when if we can squeeze our waves in a small region of space, and it is not a normal situation where we can consider any wave which is spread over a small region of space. It can only possible if I superpose so many number of waves. When we superpose so many number of waves which is related to a particle, having small difference in their what do you call in their small difference in their wavelengths or wave number and frequencies, and we superpose them depending on their condition of superposition. We can obtain that certain condition where amplitude is maximum, where amplitude is minimum. From there, we can only find out the concept of wavy nature, a particle nature related to waves. We will come later on next day. How can we think about the wave nature related to a particle as well as vice versa? Okay, thank you. Hello, good morning, students. On last day we have discussed about de Broglie proposal and how it emerged from previous experimental observations and other phenomena, and how it correlates with other existing theorems, how we can consider any kind of wavy nature behind a particle or vice versa. Okay, as we have discussed in front of us in our board, as we have discussed earlier, that this is the proposal of wavy nature, particle nature of light, and as we have mentioned earlier, that this is the proposal where exactly what a wave is. So those are mutually exclusive to each other, and how can we relate them? And in order to relate them, Okay, we have proposed that. We have proposed that once again. Let me see. We have proposed that let us learn about phase velocity and group velocity. Let us learn about phase velocity and group velocity. In phase velocity, group velocity, we will basically want to learn about velocity with which a single wave amplitude move forward, or better to say, any single wave move forward, and as well as we will learn that how group of wave move forward in a through a medium. Okay, so today we will understand how a single wave move and what is the velocity with which that single wave move, and how a group with the velocity with which a group of wave moves forward. But it is difficult experimentally to predict the velocity with which a single wave moves. It is very tough, and experimentally it is almost impossible to find out the velocity of a single wave. Okay. Now let us learn about phase velocity and group velocity. Phase velocity basically is the velocity of a particular phase of a wave. Okay, or single wave. Particular phase means in your board it is already shown here. I have drawn a wave on which there are so many dots I have chosen. Those dots define different phase points. As we have learned from class 11 that each and every point define a different theta or phi related to a wave. Since it's a progressive wave, so we have modified our expression of standing wave in such a fashion where once we continuously, if we changes our time, then we will obtain different position of that wave. Depending on that, the amplitude will, the displacement will define. So now we are observing a particular mathematically observing how a particular phase point moves forward, how a particular point moves forward. So in this section, that's why we have considered the phase part individually of above wave, as we have shown in our board, that that phi xt equals to omega t minus x by v, as it is shown in your wave displacement related to a single light waves. Okay, and let us differentiate this with respect to time. Then we have obtained that if we differentiate this to time according to the concept of phase velocity, as we are going to measure the velocity of that wave, and so obviously I am watching that particular phase over time. Okay, since I am observing a particular phase, so that phases changes with respect to time, we would not consider at all. So that's why we can say that the changes of phase with respect to time for that particular constant phase is 0, which suggests that if I differentiate the above equation before page, this one, omega into t minus x by b. If I differentiate the above equation with respect to t, then we would obtain omega minus 1 by v dx by dt. Okay, so the same way we have written down here, and from where we have obtained that omega equals to omega can be multiplied in both side. Then omega equals to omega by v into dx by dt, and v equals to dx by dt. Okay, this is the scenario. We have obtained the velocity of a particular phase okay, that is dx by dt, and from that above expression it is also observed that a particular phase's position is spreaded over a region. Okay, it's but I'm talking about the a particular phase, So that phase is spreaded over from here to there in an infinite duration, in an infinitesimally small duration dt. It spreaded over a space. So which is nothing but we know for what case spreaded in position and time possible. It is only possible for a wave because it is an infinite extended wave train. So any kind of spreading can only possible for a wave. So that's why we name it as a velocity, phase velocity of a wave. Okay. Here dx by dt have a constant phi is the velocity with which a displacement of a given page move forward. This quantity is known as phase velocity. I have written down the definition of that phase velocity. That is, thus the velocity of propagation or the velocity of a wave is the velocity with which the displacement of a given page moves forward. So this is overall things about phase velocity. Okay, we have taken here only single wave. Now I'm moving to more number of waves where we consider. Now let us analyze about group velocity. Okay, I am talking about group velocity. So what is group velocity? So to do that, we have to consider more number of waves. Here, for the time being, and for the simplicity, we have considered only two waves, wave one and wave two, having displacement y1 and y2, and mathematically we superpose themselves, and we have obtained based on sine a plus b and sine a sine b formula. They are added up. So sin A plus sin B ka formula had two sin and cos. So those term will appear. Okay, and what where we have written down. Let me say. Uh, uh, Let me see. Yes, here. So sin cos all the term appear here. Okay, and after superposition we have obtained such kind of wave displacement at any instant of time, where we have considered two waves, one having t and x, another one having different amount of omega and omega and k, where it is written. So it is I have skipped out. I think in certain cases there is a omega plus delta. Yeah, another one I have chosen. Let me see. Let me write two waves. One is A. Sir, we have in single wave. I have considered one as omega and another one is K, and I have changes this omega bit by an amount delta omega, as well as I have changes the wave number by delta K. So then I have added up. Okay, no need to write down this part. No need to write down this part. Okay, only since I have added up those two, and here I have mathematically derived, and I have shown here since delta omega is so small in comparison to omega, so I can neglect this delta omega as well as delta k, and the ultimate answer we will obtain is this much. Okay, and here we know that any kind of wave's amplitude, the cos term always included in amplitude part, as well as this one. This one defined as uh, wave amplitude, and this part is total phase. Okay, sine this sine sine omega t plus minus kx. So we have obtained our wave as it is. Besides, there is a wave amplitude. If we let us consider our wave amplitude as r. Okay, this wave amplitude as r. So what is r? And what are those terms present in that R? Now our R is 2a cos x delta k minus omega delta omega into t by 2 whole. Okay. Now let us find where our R is maximum. R is maximum if we put t equals to 0 as well as x equals to 0. If we put t equals to 0 and x equals to 0, we have obtained our maximum amplitude. As well as let us choose another different time and position where we have obtained once again our different our amplitude is maximized once again. So for this one to be maximum, what is should be the condition? The condition is this one should be the outcome of that phase part. And from that discussion, it is observed that x prime by t prime is basically d omega by dk. What is x prime by t prime? Now we know from the Newtonian mechanics we have learned that from mechanics it is it is velocity particle velocity. Sorry, it is velocity of of a particle. We know for any particle we need a specific position and specific time, which is coming out from the above discussions. But initially, when we have defined the phase velocity, the velocity appeared here as a spreading, but that spreading is absent in our last expression, that is x prime by t prime. This x prime by t prime is also a velocity, and that velocity depends on the spreading in wavelength and wave number or frequency in wave number we have chosen for superposition. Okay, and is called as this velocity is called as group velocity. So, in terms of definition, how can I write down the velocity, group velocity? Now, group velocity is the velocity with which maximum amplitude, maximum amplitude of group of waves move forward. As for example, when you standing or sitting on a seashore and you are observing so many waves are coming towards shore with different velocity. From the distant wave to the nearer wave, if you observe, certain waves are moving little bit faster than their neighboring waves. When all those faster waves are moving forward, they one by one they are making superpose with the frontier waves or front the waves which are coming more nearer to us. Okay, when they superpose, during the superposition we have observed the hump is bigger, the wave hump getting larger. That means amplitude of the wave getting larger and larger and larger and larger. And during that superposition, also we can observe another thing. What is it? Let us analyze those things based on the concept of superposition of waves. Okay, let us know. So here I have considered two waves. Okay, one having this frequency of wavelength, whatever you can say, and another wave I have chosen with little bit different wavelengths and frequency. Okay, if I superpose, now their amplitudes are also different little bit. So depending on their amplitudes, suppose their amplitudes are nearby, closer to each other, only they have a little bit differences in delta omega and delta k. When you superpose, then you can obtain that this is the point where they are superposing with different with destruction. That means destruction will appear here, will resultant with amplitude becomes zero. Whereas if you observe this point, this point, you can observe that here is another same phase point. Constructive interference will happen. So, so if you move gradually, then there is a possibility that you can obtain a superposed wave having spreaded over a space, but the separation between consecutive peaks are getting larger. Here, the separation between peaks are smaller. Here also, the spreading between the peaks are smaller. So as soon as you increases the number of waves, the separation between the peaks getting larger and larger enough, such that one peaks is there and there is no any other peaks you can observe in the screen. So you can only consider a single peak as a position of a wave group of waves, which is now suppose you have increased the number of waves more 10, 50, 100 waves and 1000 waves, then there is a possibility that at certain number of superposition the the waves look like look like that a point, or not spreaded that much as it was it was, okay, as it was observed for small number of waves. So as soon as we have increases the number of waves more and more, we are getting a small spreading of a wave, which suggests that I can now designate instead of infinitely extend wave train to a pointed things, and similar as a particle having a fixed time and a fixed position. Okay, fixed time and fixed position, similar to as a particle as we have obtained in Newtonian mechanics. So that's why we consider this group of waves may be the near about consideration of a concept of a particle. So that's why in quantum mechanics we consider group of wave is nothing but the wave like nature of a behind particle, or the particle which is moving in so fast that we could not observe its every properties related to that particle, rather than we can only signal certain light coming out from that propagation, and when we superpose those lights and mathematically analyze through Fourier transform or so, then we can obtain a particle kind of feelings. And de Broglie's hypothesis basically pointed down on that direction, that we can obtain a wavy nature of that motion of a particle, or the vice versa. A wave is propagating towards a direction, and we can expect a particle is moving towards that direction with certain momentum and particular energy E. Whereas if we have a particle concept initially, we know its momentum and energy. How can we find its wavelength? We can obtain by this superposition principle as a wavy property, and which is relevant to a particular wavelength. So this is the logics behind the de Broglie hypothesis. So de Broglie hypothesis can only be visualized if we go through the concept of phase velocity and group velocity, and the concept of blackbody radiation, as well as the concept of Bohr theory. We can only visualize this de Broglie hypothesis. Okay, thank you. Today up to this. From next day, we will practice few relation of de broccoli, related to de broccoli, for exam purpose as well as exam purpose. Okay, related to both page velocity, group velocity, as well as other things. Okay, thank you.